Hey, uh, yeah, hi Animesh. How are you doing?
Yeah,
How's
hi
it
Paul.
going?
Yeah, it's good.
Okay, how was your day? It was pretty busy, I guess.
Yeah, as you know, it's weekend, so
Uh,
anyhow, it could be good only.
okay, great. Yeah, so actually, as we know that this will be a kind of mock interview, so would you like to introduce yourself?
Yeah, yeah, sure. Okay, so as you know, my name is Animesh Kumar Shukla, and I am working as a software engineer as in Temenos India Private Limited. It is a banking software company, and I am working there as a microservice developer. There mostly I work on Java, DevOps, and databases. So this is my work background, and apart from this, I am graduated from Chhattisgarh Swami Vivekanand Technical University. I did BTech from there. My college name is uh, Rungta College of Engineering and Technology, Bhilai. Apart from this, I was also part of Smart India Hackathon 2020, and at that time we were able to reach up to final round. Okay, and also I worked as a intern at Teot System Private Limited. There I worked as a web developer. There I worked on some real world project like CRM project, and the most technology that I worked on most there as in like front end technologies for web development, HTML, CSS, JavaScript, Bootstrap, and Angular JS for the JavaScript framework. And for the backend programming, I worked on PHP, and for the database I used MySQL. Yeah, so this
Okay,
is my background.
yeah, sure. So, what's your preferred language of coding, basically?
Okay, so basically, I am comfortable in both C++ and Java. So
Sure.
if it is a simple question, then I prefer to go with C++, or else
Okay.
I can do in Java also.
Yeah, okay, yeah, sure. So yeah, maybe I have few questions to you. I'll be sharing you the link. I think can you open the link once and
Yeah,
share your
yeah, yeah,
screen?
yeah, sure. I am sharing my screen.
Okay.
Here, here. Is it visible?
Yeah, I can see.
Okay. Yeah.
Okay, yeah, sure. Let me add the question.
Switch to the next questions. Okay. Okay, I got the question. What is this? Given a head of single linked list, reverse the list and return the reversed list. Okay.
Yeah, so take a moment and you can go through the question.
Mhm. Okay, so if this is a linked list, and this is not an array, so we will definitely have a different approach for this. Okay,
Yeah.
so yeah, so I will start writing the code as okay.
Okay, so before going to start writing the code, can you actually also look into the holistic view of the question, like the constraints, etc., and see that you are comfortable with it?
Yeah, see, it is like a normal single linked list. If there will be no head, that means
Okay.
head is pointing to null, then I need to return null.
Okay.
Okay, yeah. And if there is like nodes, then I need to run my reverse logic.
Okay. And the constraints is like then in the last line below.
Okay, yeah, yeah, here also. Node value, the number of nodes in the range, okay, 0 to 5000.
Okay.
Okay, and node value could be less than, okay, less than 0 also.
Yeah.
Okay, so, okay, let's see. First thing is we need to check the head if it is null. If head equal to null, then we can return the head. Sorry, head. This is the first condition we can add. It is a corner case. Definitely, if there will be no value, then we will not be returning anything.
Yeah. Absolutely. Yeah.
Yeah. So after that, we need to reverse. There is a pointer also, so we need to take care of that. And yeah. So what we can do here, maybe see this is the head. We can make one temporary node and we can move here yeah, see we need to traverse from first to end, right? And every time when we are moving, we need to put this the current node to the next node, right. I'm not able to explain that. Just see, if it is the first node, okay, this is the head node, and the next node is second. For this example only, this one and one is pointing to 2. Okay,
Mm.
so what we will do on our first step, our head will point to 2, and this one will point to this one will point to 3, and 2 will point to 1. So
Mm.
by this way, what we can do, we will reverse the first two nodes, and
Yeah. So
uh,
maybe can you write this algorithm on the board?
yeah, yeah, here I think I'm right.
Yeah, yeah, I can write here.
Yeah, yeah, okay. So okay, steps steps I can write. First step. What we can do, we can create one node. Okay, new new node, and we will assign as null. And the okay, this is the initialization. Maybe in the main reverse logic. Okay, I will write the main reverse logic itself. Okay, so I will write a temporary node. Okay, and what it will do, it will we are changing the head node, yeah, uh, if I will change this link after 1 to 2, between this there is a link, right? If I will change this link, then our link could be gone, and we will not be able to access that. So what we will do, we can uh, like we can save the 2 first. That means head's next value. Okay.
Okay, so I have a suggestion. Yeah, you can also put that in English. So in the pseudocode, you can write the steps in code.
Okay. Okay, let's see. Um, okay, create a temp node. Is it fine?
Yeah, yeah, sure.
Okay, create a temp node, and then store the current nodes next value to um, temporary node, temp node. Okay, and after that, what we will do? Uh, uh, okay, see, this is like create a temp node. Store the current next node. Okay, this is like we preserved this, and now we need to run that we need to put this 2 between 2 and 3,
Mm.
right? So now what we can do, yeah, before this also, this is like the main condition. We can use one more variable, and what I can do, create new node, like temp node 2, temp node 2. Okay, and after that, what I can do, I can point my the head value to this value. Okay,
Yeah, yeah. Write that point. Like, don't write a variable name directly. You can write like next node value or something like that.
new node value, new node,
Okay.
create new node, and then what we can do, we can assign this heads value to this new node. Okay, assign heads value to new node. Okay, for this, there is one temp node, second is new node. Okay, there will be no conflict. Now at the end, what we can do, see, uh, we have this second node, we have our head also. Now what I need to do, I need to remove this link. I need to point this uh, to our new node, and new node next to 3. Correct.
Hmm.
So what I can do, I can do this current current nodes next. This I can assign to our new node. Okay,
Hmm. Hmm.
and yeah, no. Before this, we see, if we will do like this, then I think after this linked list, it will be gone. Correct. So before this, I need to assign that new nodes, that current nodes next to our new nodes next. And
Hmm.
I don't think like I'm able to
No,
explain
that's
it well.
fine. Yes, that's fine. Maybe take 5 more minutes and write all the steps once.
Okay. What I will do, this new nodes next to this current node next value to temp node. Yeah. So what I will do, temp nodes next, if it is fine.
Hmm. So
Okay.
yeah. Hmm.
What you see, I will explain once again what I am doing. I am creating one temporary node. Okay, after that I am storing the current nodes next value. That means if we see this example, if I am at this one node number 1, and from here I am moving to node number 2. Okay, so this will be our head, this will be our current node. So what we are doing, see this current node's next value, that means this second value, I am pointing to one temporary node so that I will preserve this value.
Hmm.
And after this, what I'm doing, I am storing yeah, I am creating one new variable.
Hmm.
I am creating one new node, and then I am assigning heads value to that new node.
Hmm. Yeah.
Okay, and then after that, what I am doing, I am changing the heads, that means current variables next value. That
Hmm.
means that pointer I am changing. So what I will do, I will change that pointer to 3. That means it will point to
Hmm.
3,
Hmm.
this temporary node's next value. Okay,
Yeah. Yeah. So
and then
everything looks good. Just one correction. For one it will be head, but for preserving two, two will not be head, right? So you can rename it to something else. Head will always be one, right, or five once it gets
yeah,
reverse.
correct. Okay, yeah, correct.
So you can mention it like current, maybe assign current value to new node in point four.
This one, right?
Yeah.
This one, right? Yeah, correct. Current value to new node. Yeah, it will be correct.
Okay, and you will be doing this till you will see that next value as not exists or something, right? So you can add that
Yeah.
point too.
I need to run that. If I will get that null next, that means current dot next equal to null, then I think I need to stop there.
Yeah, can you add that point, or
Yeah,
it
yeah.
will be
Okay. uh, if current nodes next value is null, then stop. Okay.
Okay. Yeah.
Okay,
Yeah.
let's
So
start. Yeah, yeah,
yeah, now you can start either pseudocode or actual code according to your comfort.
yeah, yeah. Okay. So I will start the code itself. Okay. So I will see there is a create temp node. This is like it could come under our loop, right? So I will start the loop, whatever the condition I'm defining at the seventh point.
Hmm.
Um, um, if a while head dot next, no, sorry, head dot next or head.
I actually told you that it will be current, right? Not head.
Yeah, but here it is head, right?
Yeah, they will provide you head. You can copy that to current and keep iterating current, right?
Yeah, okay. Yeah, so here I can create one new node current equal to head.
Mm.
Is it fine?
Yeah.
If current not equal to null, then I think we can run our loop. And yeah, I am creating. Okay, what is this? C text and images copied. Allowed temp equal to uh, this node equal to temp. What we are doing here is store the current node's next value to the temp node. That means this current's next value we will be storing current dot next, we will be storing in our temporary node. Then after that we are creating one new node and then assign the current values to that node. Okay, so I will create one new node. um, New node equal to I'm assign the current value. So I will assign here current value, and then mm, here at the fifth point, new nodes next to temporary nodes next. That means this node's next value I need to store at here after this, like temps next. So I am writing here temp dot next equal to new node dot next. After this, current node's next value to the new node. That means this is the current value, right? I need to change this. That means our new current pointer will be second position. What I think so. So let's write um, current dot next equal to new node. Let's see this, and at the end we need to return current, not current, new node. Okay, let's see. Okay, but this new node we will not be able to return if we will define this inside this loop.
So is that required first of all because you are not using it right anywhere? Instead of putting new node to current and then assigning current dot next equals to new node, can't you do current dot next equals to current directly there?
Current dot next equal to current.
Mm.
Okay,
And I think you can comment up 18th. That's not required.
this line.
Yeah.
Okay, but here we are doing this right.
Mm. That also you can keep it current dot next.
Acha, yeah, yeah, correct. Then at the end we can return current value.
Mm, correct.
Okay, let's revise this.
Uh,
We
but
can check this.
you are doing while current not equals to null, so that will exit. that will exit when current equals to null, right? So
Hmm.
when you return it after that, it will be null, obviously. So instead of checking current not equals to null, okay,
Current
can
dot
you?
next.
Hmm.
Yeah. Okay.
Uh, yeah, cool.
We can do the dry run. Uh,
Mm. But I have a doubt. So
yeah.
current dot next not equals to null means by the time it reaches 5, it doesn't do. So by the time it reaches 4, what it does, it will actually reverse 4 to 5 or 3 to 4 according to the logic.
Just a minute. Can you please repeat?
So by the time the current value is 4 in the while loop, can you dry run like what happens at current equals to
Yeah, yeah,
4?
yeah. I will do the dry run.
Okay.
See, if we are using this current value is head, right? So
Mm.
current equal to head, and then what we are doing, first here, we are in this temp node. Can I use my notepad
There
mobile?
itself you can comment, make a comment and double slash and you can write.
Yeah, yeah, okay. Here itself, I think. Okay, so for the first step, what it will do, current value will be 1. Um, okay, temp value will be 2. Temp value will be 2, and so and after that, temp dot next, and current dot next. Okay, that means, okay, temp dot next means current dot next. That means 2 dot next. Okay, uh, just a minute. I'm a little bit confused. Temp next, and that means 3. Current dot next. Next. Okay, here we are assigning that 2 itself. If we see
Hmm.
temp dot next to current dot next, that means it will be like 2, 2, and then like this
Hmm.
it will be. So I think this is not
Yes. Yeah. So the
correct.
logic needs to be changed, right?
Yeah,
Or
yeah, yeah, correct, correct. That needs to be changed. We'll figure it out. Okay, this current is head. Mm-hmm. Temp means this. Uh, I was using this just to preserve this current's next value. That means so no, sorry, current's value. I was using this variable to preserve this value. This value.
yeah. So basically, your idea, what I got is like for two, you will take the previous value and you will make it as next to two, right?
Yep, yep, correct.
Yeah, yeah, just think in that way and see for two, if one is stored in which variable, if so, what variable it is, and should that variable be a local variable or global variable? Think about it.
This is current or next. Current means it is head. Mm, okay, 1, 2, 3. Just a minute. Node is current dot next. See, current dot next we have stored. That means this is we have stored. So we do need not to take care about this. We need to change this current value. That means this value, if we will this is current value, right? So if we can assign this next value to here, and after that we can change this link.
And I'll
See,
give you one suggestion. The naming of the variable, keep it like what does it do, right? And what does it represent? So instead of keeping temp, keep it like next or current, something like that, right? So make it next, okay?
okay. Actually, see here there is already one.
Next variable.
next
Okay.
value. Yeah,
Can you make it next node in that case?
yeah, okay. Maybe NXT I can use.
Anything, yeah. Hmm. But next node will be better
Yeah, next
because
node will be better,
hmm,
correct. Next node.
okay.
Yeah, okay. See, next node, that means two we have preserved. Now,
Hmm.
what we need to do, I need to change this link. That means 1, 2, 3. I need to assign current values, next value to the new
Hmm.
node's value. That means next node values to next, right? Wait, I will write and I will tell you.
No, no. Take a middle element. Don't take a corner element. So suppose say take it three. For three, what will be the next node? So you are basically storing four. So after line number 17, can you write a comment with the double slash like it will store four? Okay.
Oh, see, actually, we need to move like two with two variables, right? That means first we will what I can say. Uh, just a minute. First, I
So
will
I
rotate this
was
1 and 2,
so
and
maybe
then
I'll comment it like okay. Just 1 second.
okay,
So for current equals to 4, let's take suppose a 3. So what will they store? Next value will store 4, and
hmm
so you are basically now making temp means next node. Okay, next node dot next, which is 4 dot next. What you are doing? You are assigning
five,
it to current dot next. Current is 3. Current dot
3.
next is 4. Uh, so
Yeah, see,
next.
we need to refine our logic. Actually, this logic was not correct. At that time also, I was facing this issue.
Correct. So
Yeah,
basically, we were doing 5 next is 4.
yeah,
And current dot next is basically 4 and equals to current. I mean, basically, you are making 4 go to 3. Okay, so for current 3, what you're doing 5 doing to 4 and 4 doing to 3. So this is not required here because at the step 3 we are just focusing on making uh, the reverse of 4 to 3, right? uh,
mm,
or we can even just focus on making the previous element. So our focus point should be like, I think at 1 will not do anything, but once we come to 2 we'll reverse 1 to, I mean 1 to 2, and once we go to 3 we'll reverse 3 to 2. So what we are doing, instead of concentrating on 3 and 2, we were concentrating on 3, 4 and 4, 5 means the
yeah,
next
correct,
elements.
correct.
So now you can concentrate on just the previous element, which is to how to interchange that to next element. Okay.
Okay. Okay. Previous element also we need to preserve, right? Yeah, correct. You're right. Mm, okay. So what will be like? Okay. Here we can see if we can start from 1, and this 2 is pointing to 1 and 3 is pointing to 2. Okay, that means
So
the next value will become previous value for the
yeah.
current node.
So one observation and a clue to you is like so when you enter for current value 2, you need something to refer from global scope. Okay, like from the previous loop you are storing something, and if you are using it in the next loop, so that should be a global variable, or otherwise for every iteration of a loop that value will disappear, right? So there
Hmm.
should be one global variable which will store that current value as something, and that should be referred in the next loop. Can you try that?
Okay. Okay, so I will create one new variable. Control C, previous value I can write, right?
Yeah.
Prev, and for starting I can point this to null.
Mm.
Mm, okay, so we have created one previous variable, and current is 2. Current dot next means it will be 2 for the first step. Okay, 2 we are preserving. Now we need to preserve our 1. That means current value also. Is it?
So in prev, basically when the current value becomes 2, prev should be 1. Okay.
Hmm.
So in the first iteration, what you do in the last step, you can just make prev equals to current.
Okay. That means at the end.
Yeah. So that by the next loop, it will have the previous as the current value.
Yep. Correct.
Okay.
Okay. And then
So now you should take next node, correct? But that next node, should it be local or global also, you need to think. For now, you have taken it as local. Okay, so we have
local.
got
Yeah.
now next value. So since now you have got next value, you can do current dot next equals to prev, right? That is what we need to do.
Current dot next equal to prev. Yeah. Yeah.
Hmm.
Correct. 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 You're right.
So add that line after 18.
That next equal to previous value.
And
Okay. After
now
this,
current will become that next node, correct?
the yeah next node.
Yeah. So now you can do current equals to next.
Next. Sorry. Next node.
So
So
before doing that, actually to do current dot next equals to prev, you should do
this
prev
is
equals to yeah. Can you cut
prev,
that
prev
25
equal to
line?
current.
Yeah, I think that you should move
We need to preserve this. That means we need to put before this line.
before
Otherwise,
19.
yeah, before 19,
No, no. Yeah,
before 21,
before
right?
21.
Here we are
Correct. Yeah.
changing the current value.
Yeah, yeah, sure.
Okay, so I think this is the yeah. Okay, so here we will not be returning current value.
That is fine. But what about 23 and 24?
This will not be there as we have
Okay.
changed the whole logic.
Comment it.
Yeah.
And yeah, so I think by the time you reach 5, you will check for current dot next, okay, equals to that.
Hmm.
And we see, yeah, it's null and we'll return that 5. And the 5 will be the head value. So that should be correct. So current is good. But yeah, current equals to next node will happen for 4 actually. So 4 will return the 5. But in this case, I think so. Basically, you should check for current not equals to null.
Here,
Yeah, correct. Yeah,
here, right?
yeah. That should be current not equals to null.
Yeah, correct.
Okay, yeah. Yeah, just check for the syntax and everything. And if it's look good, then you can run it.
The syntax is I think good. Yeah, it's looks fine. I will run this. Okay, so output is null. Okay, we are
So,
returning current, right? At the end, it will
mm,
be null only. So we cannot
mm,
return current. Maybe we can return the current's previous value.
that will
It's
be
okay.
prev.
Yeah, previous. Just a minute.
Okay,
This one,
five
two, three,
four.
four, five, five, four, three, two, one. Yeah,
Okay.
it's running.
So other than empty, there is no other edge case, correct?
Mm-hmm. Okay, so it is running. It is hitting all the test cases or only the
No,
test.
this is only for that particular test case you are running.
Okay.
So I should actually submit it. Let me submit and check.
Okay.
So this, yeah, it's accepted.
Okay.
Cool then. Then let's move to the next question.
Okay.
Are you able to see next question actually? No.
No, no, I'm not able to see that.
Yeah. What? How about now?
Moderator has switched the next question. Yeah, now I can see that. I will be running this in C++. Okay. What is this? Given a non-negative integer x, compute and return the square root of x. Since the return type is an integer and the decimal digits create an only integer part, you are not allowed to use the built-in exponent function. Okay, power we cannot use. Okay, for this I need to think, as I don't know
Mm. So you just write whatever the first thoughts that come to your mind, right? Write them in plain English,
yeah,
high level steps, and then
yeah.
you can think about sub steps.
See, if I go to basic maths, whatever we have learned, okay, in
Mm.
our school, so at that time what we do generally, we get the factors of a particular number, and then we make the pairs. If we are able to make the all pairs, then uh,
Yeah.
from every pair we will pick one element and we will multiply that, and that will be the square root.
Mm. So
Correct.
here in the question, what this is like compute and return the square root of x, right? So
Yep.
are they also mentioning that the value which they provide is a perfect square or not?
No, no, no. See here at the example number
Mm.
2, they are showing the square root of 8 will be 2.8284 something.
Mm.
And
Mm.
since this is the decimal part, so decimal
Mm.
part we can truncate and we need to return
Correct.
2.
So that approach which you says will only work for perfect squares, right?
Yes, 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 correct.
Okay. You
So
can think other alternatives.
yeah, there was one algorithm that we use, but I'm not getting that algorithm. That is, I think, something Newton's method we use.
Yeah, Newton's method is correct.
Hmm.
Instead of writing that, can you just try like writing the steps? What I mean, don't use any terms like Newton or anything.
Hmm.
Just write high level steps, right? We need to first step. You can write like we need to compute the square root of a input.
Okay.
Yeah. Can you write that
Compute.
step?
Compute.
Mm. Input. Okay. So we are done with the actual steps. Now we need to think about sub steps. So the sub step for this we can think like can't we think like given a value x, we
Hmm.
should find a number y so that y into y equals to x. Correct.
Yeah, correct, correct.
Yeah. So if the range of x is suppose okay, if we take a value x, what is the possible range for y? Can you think about that? Because if 4 is given, the value of square root will be between what value to what value?
Yeah, yeah. See, if see, we can take example as 4. If we are
Mm.
we are getting 2 here, definitely it is half of this.
Mm.
Okay, but in the case of 8, we are getting less than half.
Mm. So 8 will be between 2 to 3, right?
Yeah, it will be between 2 to. Okay, okay. Yeah, you are talking about that square root. Yeah, correct.
Square root, okay.
Hmm.
So one thing definitely it will be between suppose if the value is given positive, so it will be between 1 to x definitely. But
Yeah,
is it
correct.
also possible that it will be between 1 to x by 2?
Yeah, yeah, correct. That's what I
Uh,
wanted to say.
okay. So can we even refine it more, or do you think x by 3 will also be possible? No, right?
It is a square root, right? So I
Uh,
don't think if we do like x by 3, that means 8 by 3. It will
uh,
be like 2 point something.
and
Maybe it will be less
4
than that.
4 by 3 will be 1 point something. So yeah,
Yeah, for
and can it be x by 2 also, the square root value?
can be like, see here, for in the
Mm.
case of 4, it is x by 4 only,
Okay.
x
So
by 2 only, sorry, yeah.
can you write that step like the range of result will be between 1 to less than or
Of
equals to x input by 2.
result is between, okay, in between 1 and x by 2.
Yeah, but x by 2 can also be there. So it will be like maybe you can give a square bracket after x by 2. So it means it will consider x by 2 also. Okay.
Something like this.
Yeah. And one, yeah, one also square bracket. Yeah.
Yeah, 1 to x by 2.
X by 2. So it is
X by 2.
inclusion. Mm.
Hmm.
So now, why don't you just iterate all the values? That is a step that comes to our mind now, right? So iterate the values between 1 and x by 2, correct?
Hmm.
And see if the value which is obtaining is less than or equals to x, and the next value, suppose say if value i, i, I square is less than x, and if I plus 1 into I plus 1 is more than x, so that means the
We can
value
return I.
return I, correct?
Yeah, yeah, correct, correct, correct. Okay, so I will run the, we can run the loop
Mm.
from 1 to x
Mm.
by 2
Mm.
by
So
2.
what will be time complexity for this algorithm?
uh Maybe O of n by 2. That means O of n only. It
N
will be
only, correct?
linear time complexity.
But the constraint says the value of x is not very limited. It can go till 2 power 31 minus 1.
Oh
So
yeah.
there is a chance that this will not be accepted because it has to iterate those many times, right?
Mm-hmm, correct.
So can you think of optimized solution? Now that one approach is to loop each and every value between 1 to x by 2.
Yeah, yeah, wait. I will write this first. I will
Mm.
loop from 1 to x by 2, and here
Mm.
what we can check. Uh, we can do I into I. That means, yeah, I into I can write. I
Mm.
into I is less than
Or
x,
equals to.
less than or equals to, correct. Less than equal to x, or there will be one more condition, and it will be greater than,
Not x, I into I.
yeah,
I
I
plus 1
plus
into I
I,
plus 1.
yeah,
Yeah.
I plus y, I plus 1. I am writing that only. I
Okay.
plus 1 into I plus 1.
Cool.
If it will be the case, then we can return I.
No, in the less than or equals to, in the next symbol I plus 1 into I plus 1, it can't be equal, right? It either can be I
Yeah,
into I or, yeah.
it will be greater.
So then you can
Greater
return
than.
I. Yeah.
In this case, we can return I. And if it is not the case, definitely it will be the case because we need to find the square root.
Yeah, the value will be between 1 to x by 2. So,
Yep,
yeah.
correct.
So,
Okay,
yeah, now
so
think about how to change the time complexity now.
okay, see, this is like, okay, if we do the half only, also,
Mm.
then it will be very very high.
Mm.
So see, as it is linear, so can't we use binary search here?
Yeah, so binary search, what will be time complexity of binary search?
Log of n,
So it will be less
definitely
than linear.
less than O of n, correct.
Mm.
Yeah, so here
So
I will write, here I will write something called O of n also. Okay, so okay, this is linear time complexity. We can run a loop and we can get the square root. uh,
see, you need to explain me in the algorithm in English so that I can see whether it is correct or not before you go ahead. Okay, like binary search, you will apply for what actually?
See, this will be like, we know this condition, right? We are doing almost half. in this
Hmm.
linear method also. We are doing it
Hmm.
half. Now
Hmm.
what we can do, we can run from here to here. That means it will be our
Hmm.
start value, it will be our end value,
Hmm.
and we can find that mid definitely, and we can
Hmm.
check whether mid into mid
Hmm.
is less than equal to that x value.
Okay, so
If
if
it
it
is
is less than or equals to, then what you will do?
if it is less than, then okay, if it is less than, then I will increase this start value. That means from what
That
we
you will
do,
make it to mid.
yeah, it will, I will do, move it to mid, and then I will search on the second half, which
Okay.
is between mid and
Hmm. Hmm.
that x by 2. And
Hmm.
if it is greater value, then I can do this, I can point and to mid value.
Hmm. And anyway, we are already checking with mid. So whatever the mid computation you are doing, you can do in that. And after that, instead of moving to mid, you can move it to mid plus one. Okay.
Yeah, for the start value, right? Yeah, yeah,
Yeah.
for a start, yeah, mid plus 1, correct.
Okay. And if it is suppose say the value mid into mid is greater than x, so then what you will do?
Greater than x, then I will do and equal to mid,
Hmm.
or mid minus 1, mid minus 1, I
It
think.
will be mid minus one because we don't repeat ourselves, right? We already
Mm-hmm.
computed mid. Yeah.
Mm-hmm. Okay. So can I start writing the code?
Are you sure
Maybe
about the steps?
see this is like linear approach, right? We have this. We just need to break it into binary search.
Cool. Then you can start implementing.
Yeah, okay. First, what we can see, if x is okay, if x is 0, okay, if x is 0, then we can return 0. No, sorry, type caps lock. Then 0. This can be a corner case, and then after that, what we are doing, we are like
And also, you think about it for the values between 0 and 1, what will be the answer?
values between 0 and 1. It will be 0 only, right?
Yeah, so instead of writing x equals to 0, can you write if x less than 1?
Okay, x is less than 1. Yeah, because that will be floor value.
Hmm.
Okay, x is less than 1, then we will return 0.
Hmm.
Okay, now what we can do, there will be one result variable, okay, that we will be returning. So I can like assign it to 1, and there will be one start variable which will be pointing to 1 definitely, and there will be one end variable that will be pointing to x by 2. Okay, after that,
Hey, array index starts from 0 or 1?
so this is not an array, right? This is like a range.
Um,
We are already we are considering 0 here.
okay, got it. Mm.
Yeah. So if we are working this like searching this
Got it.
searching
Yeah.
algorithm in array, then we
Yeah.
will include 0.
Sure. Okay.
While uh, while start is less than equal to end, at that time, till then what we need to do, we will compute one mid variable, mid equal to start plus end divide by 2.
Hey, 1 second.
Yeah,
So,
sure.
what is the max? I mean, what is the maximum value of end?
Maximum value of n, see, if we are considering 8, then it could be 8 by 2, that means 4.
Okay. Okay,
Yeah,
got it. Sure. Okay.
okay.
Mm. I was checking if start plus end, if it overflows, the value will be wrong. But yeah, it won't overflow, so we can take sure.
Okay, this isn't equal to mid. Okay, so we are doing this. Now we will check if mm, mid into mid is less than what? Less than x. Then what we will do? If it is less than x, then we will our new start will be mid plus one. Start equal to mid plus one.
Mm. And what if it is equal? You will directly return it, right?
Yeah, if it will be equal, then we can directly return.
Okay.
Um, else if mid into mid is greater than uh,
X.
x, then what we will our new end will be mid minus one.
Mm.
Minus one.
Mm. So write that condition equals condition also.
Yeah. Else, do I need to write that condition or I can simply write else?
You can write else only and then
Yeah.
return.
Yeah. Then mid.
Hmm. And once this while loop is exited, what you need to return there?
Uh, that time also I think we need to return the floor value.
No, basically, when will this while value exit? It will
Hmm.
exit when the start and end are equal
No, no, this
or great
mid
start greater than end.
mid value if it will return.
No, no, while loop will get stopped at for which condition? I'm asking that. What is the exit condition for while loop here?
This is like when start and end will be is less than equal to end.
That is
Start is less.
running condition. Exit condition I'm asking.
Okay. Just running.
Exit condition is when start greater than end, right?
Hmm.
But anyway, instead of writing start less than or equals to end, think about other condition. Maybe while start is not equals to end, does it look so good?
Start is not equal to end. Yeah, we can write that also.
Okay, because what I'm thinking, or otherwise you can keep this same, just remove that equals, because when start equals to end, it means that the size of the thing will become one, right? So mid,
Hmm.
so at that point, again, we need not do start plus a start, we need not change the start value and end values, right?
Hmm.
So then directly, if start equals to end, it becomes you can come out and you can return the mid. I mean, mid will be equals to start and end, right? So you can just return the mid or start anything.
Okay, but see,
Mm.
if we will return this mid here,
Mm.
the bid as mid is like a local variable. If we will go out,
Mm.
then this mid will be lost.
So then you
So
can return start or start plus end by 2.
just try returning start.
Yeah.
Okay. Can I run this?
And yeah, so the time complexity is O of log n, right?
Log n, yeah. Every time we are doing like half, we are
Mm.
considering
Mm.
only one portion.
Mm. Log n base 2, correct?
Hmm.
So it will be how much log n base 2 of 2 power 31? It will be 31, right?
Hmm.
Hmm. So it will run for 31 times. So okay, fine, you can run it. Let's see.
Let's see, yeah, correct. Okay. If input is 4, then output is 2.
Can you try giving 8? Is that possible? Go to test case
Test
maybe
cases
8.
8. Run. For 8, it is giving 3.
3. Okay. So in that case, it means that you are returning start. That start value will be like, yeah. So we have reached a point where we didn't actually find mid into mid was less than x. In that case, only we'll do start equals to mid plus one, right?
Okay, see here we have considered
Mm.
one global variable result. So here
Mm.
maybe we can store that mid into this variable and then we can return the result variable at the end.
Yeah, you can do that.
I can try that. Maybe
Mm.
it will work. Before returning, I can
No, no, no.
this.
That you should be keeping outside of else, below else.
Yeah, yeah, yeah. You're right.
Mm.
Result equal to mid, and then
Mm.
can return res.
Okay.
No, it is
Still
three
3.
only.
Yeah, so think right why it is
Mhm.
giving 3.
Correct. 8. Okay. From example itself, we can see start is
Mm.
1 and end is 4. Essay.
Mm.
Okay. Start is 1 and 4. Sorry, 4.
Mm.
And then here we are checking this condition satisfied. Then we are finding the mid 1 plus 4. Okay, 1 plus 4 divided by 2. That means it will be 2 only.
Mm.
Okay. Then we are doing mid into mid less than x. We are doing 2 into 2. It is less than x definitely. So then what we are doing, we are changing our start to 2. No, 2 plus 1, that means 3. And end will be 4 only. Okay, so here itself I think we are doing mistake.
So I think you should return result minus 1. Try that.
Yeah, okay. See, for this condition it will work. I'm not sure
Give,
if
yeah,
maybe
yeah,
for,
give another number and try.
see, for 4 it is giving 0.
So 0. Yeah. So can you make that change instead of result? Can you make it mid minus 1 at 18 and see?
Here,
There, yeah.
minus 1. And here,
Mm. Just result.
okay, run the code. It's 0 only.
Why is it returning 0? Like you are returning mid, right? Directly.
Here I am returning mid, correct.
Then how come it is returning 0? Can you run code? Okay. Return.
Here it is 3, 4. This I'm like thinking.
Yeah, see, yeah.
Here start is becoming 3. Okay, this mid, I think here we need to do something. Start plus end. I will use my pen and paper for some.
Okay.
Start, that means 1 plus 1 plus 4 divided by 2, that means it is 2. And if 2 into 2 is less than x, it is 4. 4 is less than x, then what we are doing, we are at our start value is mid plus 1. Mid plus 1. Start is mid plus 1, that means it is 4. 3 and 4. 4 and 3. And the next step, what it will be, 3 plus 4 divided by 2. That means 7 divided by 2. It will be 3. Next time. Okay, and then 3 into 3 will be. I think there could be yeah, something we need to think in the logic. Start plus and divided by 2. This is 7.
See, it is failing for input 4, right? So when you do dry run for input 4,
Hmm.
so how does it go? Basically, you're starting from 1 to 2, correct? And
Yeah,
where is that
correct.
where is that range that it will be going? So okay, so since we are given n equals to 2, we'll do start less than this. We'll do the mid for 1, 2, which will be 1 again.
Yes, right.
Uh,
Perfectly correct.
so basically 1 into 1 is less than that, and you will do start equals to mid plus 1, which will be 2.
Hmm,
And now
correct.
you will check for 2 less than 2, and it doesn't go, and you will return that.
Yeah.
Okay, so then you can add equals to there, uh, equals to end, right? Yeah, you can do this. And now it will become 2 less than 2, and now we'll see mid into mid, mid, yeah, it
At
mid
that
4.
time, it will be 4. That means it will be 2. Mid will be 2.
2, yeah. And suppose say if the value is not still achieved, then we'll again go there and we'll see start, which will be now 3. 3 less than 2 is not possible. Or yeah, if it is actually less than, okay, then we need to see whether we need to return start or we need to return end, right? So definitely we need to return the floor value, so it will be end and not start. So maybe uh, in the result, right, in line 19 you can keep result equals to end.
Here.
Hmm. uh, and yeah, now try running.
Okay.
Give it.
It is working for 4, for 8. Yeah, it is giving 2.
Okay. Now can you give 2 power 31?
Here. Can I give like
Hmm.
this? How to
Okay,
give this?
how to give, we can't give. Okay, fine, then let me submit and check. Okay.
Hmm.
See, at line number 20, at line number 11, there is a overflow. Okay.
Okay. But
So
I don't.
you need to typecast that to long, mid into mid.
This one.
Mm. You just do one thing. You put before mid into mid once one bracket and put. Okay, let me type that. Uh,
Like this, right? Okay, sorry. Yeah, you type. I'm not doing anything. Long.
let- Line number 13. Where is 13?
Yeah, yeah,
Here
13 also.
also.
Here also we need to write long.
Yeah, the solution is accepted now.
Okay, that means it is
But
correct.
correct, yeah. So this will be binary approach. Okay.
Hmm.
So we can actually even more decrease the time complexity, but still that's not required because this will run only 32 times. But still, if you want to improve the complexity, there is another way as well. And also, before going that, uh, mid minus 1 mid result x, yeah. So did you understood like why I told you to put result equals to end at 18?
Here, right?
Yeah,
Um,
because the value result will be between starting and ending, but we need to see, we need to give the below value or above value, means the floor value or top value, right? So by the time this loop gets exited, the x value will be like greater than end and less than start, correct?
hmm,
Because the start will be greater than end. So
hmm,
between end and start, which is greater, start. So that will be the top value. But if you want the floor value, you need to return end, right?
hmm, hmm, correct.
Okay, so that is it. Now there is another method called Newton, which is also possible, tries to decrease even more complexity. Can you think about how can we even decrease than actually doing it by two, right?
Hmm. This is the binary approach. From linear, we came to binary.
Yeah.
Okay, this Newton. Mhm.
So if we see for value 2, okay, and the result 8, okay, uh,
Okay.
if for value 2 for result 8, if 2 has to be multiplied by some number to make it 8, that number will be 4, correct?
Correct.
So basically we just need to iterate from 2 to 4 if we want to see if there is any value that will make it to 8. Correct. And in the same way, what we can do, we can actually take the value x and see while x is added up. Okay, but yeah, sure. This is also looks good, so I'll accept this. And also, yeah, I think. Do you want to take one more question, or let's go to feedback?
Yeah, your
I
wish.
Yeah, I think let's go to feedback session for now.
Yeah,
And
sure.
yeah, so cool. So let me take the first problem, reversal linked list. So
Hmm.
in reversal linked list, yeah, so you have taken you have written, yeah, so first step is like you have directly checked for if head equals to null or not. So that is good thing. So because I always suggest everyone like start with edge cases first so that you will not miss it in the end. So
Yeah.
we have written that, and that's good actually, so we'll not miss those cases. And yeah, after that actually when you wrote the algorithm in English, you were trying to put like a pseudo code in algorithm, right? So
Hmm.
yeah, but I told you to write in plain English, so that's the same way maybe you can do it further as well. So
Hmm.
because when you write it in plain English, you can even think about it and change it and also write the sub steps of it. But if you write the pseudocode again, we actually need to think holistically like entire thing. But if you write in English, we can just so that will be helpful. So I always suggest everyone like write the algorithm first, because once we write the algorithm, we have something to refer that needs to be implemented, right? But if you don't have an
Hmm.
algorithm, we'll not have any reference to implement. So we'll think what we need to implement. So thinking and implementing, if it actually goes side on side, some what we call efficiency decreases. And yeah, so that's the reason I'll say to write algorithm. And yeah, you have written it, so I appreciate that. And after writing the algorithm, while implementing, yeah, so you were giving the variable names like temp and uh, next, right? So yeah, next is good actually, but for temp I told you to replace with current, right? So yeah, that
Yeah.
will be helpful to you, because when you're thinking, you need not double think again what will be temp, whether it will be current or previous. So if we directly write it there, it will be even more efficient. So you changed it and you ran it, so that's good. And yeah, so you are able to get the logic, but since you haven't written the steps in English, so you was little confused. So instead of pseudocode, writing steps will give you even more good results. So okay, so that is for first question. And second question, For square root, yeah. So see, actually, initially you told like you didn't get an algorithm, but when I
Hmm.
told you to start thinking about the range, the algorithm came automatically from that,
Yeah,
right?
correct,
So
correct.
yeah, so that is the advantage of writing in English. And once we have one step, we can think what is the available data on it. So we know that the available data is the range that it has to be 1 to x by 2. And
Hmm.
once we have a range, we'll think about the brute force for that range. And once we think about brute force for that range, I told you to optimize, and immediately you came up with this thing, right? Binary. So
Binary
that's a,
search.
yeah, that's a good thing. So you understood the concept of when to use binary. So if we are in linear and if you want to decrease it further, so binary will be best because it will decrease it by half, right? So
Yeah,
yeah,
correct.
so that is appreciable. So you have done that good. But again, overflow thing we missed, right? So whenever we are multiplying two integers,
Hmm.
definitely we need to see that whether the range will exceed there or not. And also, suppose say here start and end, right? If both are 2 power 32 minus 1, then when adding also it will become overflow, because adding 2 power 31 plus 2 power 31 will lead to 2 power 32, and integer can't add it first place.
Okay.
So in that case also will require typecasting too long. But here, since end is always less than start, right? And
Hmm.
also both are divided by 2. So maximum value end and start can take is 2 power 31 by 2. So even if they add also, it will be less than 2 power 31. So that's the reason I told like it's not required. So but that's fine. So we can always think whenever we are multiplying any data types, we have to typecast it to next data type based on the range of that value.
Okay.
Okay, so and yeah, here also you have applied the uh, initial, what is this, edge case initially itself, so that is good. And see, but the first feedback you implemented here, right? Like instead of giving any other name, you directly put start end, and
Yeah, yeah.
yeah, so and the result. So that's good. Naming convention has been taken care. And I also see that you implemented one in Java, one in C++. So you have
Yeah.
good yeah, implementation skills in both, which is also a good sign. Yeah, so this looks good. And yeah, do you have any questions or anything to ask?
So see, thanks for the feedback first, and also see today what I learned. I need to write steps in normal English, so it will be good if I am approaching to a problem. So it this is the best thing I got today, and the next
Hmm.
thing is this the naming convention of the variable. So that
Hmm.
could be like something so that we can relate that what value it is holding, so that we don't
Hmm.
need to think while approaching to the problem or implementing the actual logic. At that time we don't need to
Hmm.
think about that. So
Yeah.
these two things I learned, and definitely I will use this to my next problems whatever I will solve. So
Yeah.
thanks for that.
Yeah, sure. So thanks for this. And yeah, thank you. Let's yeah, let's keep in touch. Thank you.
Yeah, yeah, sure. Thanks, bye.
Bye.